Hi, I'm Aaron Runk, and today we're going to be doing a setup on our SL20 Haas. First thing I'm going to do is I have powered on my machine and I have released my e-stop. My machine has come on and I have a message telling me to reset my servos, so I will hit it 2 times. Some machines have 2 alarms, some of them don't. The first thing I will do is I will come up to my machine and I will hit power up restart. As I hit power up restart, my machine is sending it to its home location. The reason why this is important is so that my MCU, my machine control unit, knows where the machine is at. Okay? So what I want to do now is I want to load the program that I'm going to be running. To do that, I will have to have my USB loaded here on the side. I will be in edit mode. I will hit F1 and I will come over to input output and I will mouse down to my disk directory. Once I have my disk directory highlighted, I will hit right enter. When I hit right enter, I am reading what is on my USB. So I have a CNC turning program that is available. That is the program I want. I will hit enter. If that program is in use, you will see down here that it wants you to overwrite the program that is in my directory. I do, so I will hit yes. You'll notice that my disk is done. This is the program that I want. This is the Haas CNC Turning SL20 program. Now that I have the correct program in there, I'm going to be using Tool 2 for this setup, and I will also be using Tool 6. In this setup, I'm going to be using a DNMG 432. Now that 2 is very important to us, and I will explain that to you here in just a second. Now in order to get to my Tool 2 so that we can find out where we're at, is I need to go into my MDI and I want to erase any codes that may be already there. I will type in T2 and I will hit turret forward or reverse, either will work. As I do that, you will see that my turret does call up tool number 2. So, with this being done, to do a correct setup, I want to be able to take and face the front of my part, and I will also have to take a light cut on the outside diameter of my part that I will have to measure for accuracy. So with this, we'll come back to our MDI page and I will type in S500 M3. So the S is going to be my RPM. The M3 is going to be my spindle rotation, and I will remember to put an end block on the end of my code, and I will push right enter. Now with that code being correct, I will hit cycle start. My spindle is now turning. What I need to do is I need to come into handle mode. I will go into a higher increment so that I can get to this face of my spindle. I'm in the X-axis or the Z-axis right now, coming towards my spindle face. I will go into the X-axis to move towards me. Now that I'm close to my part, I'm going to come back to my controller and I'm going to put the 1/1000th increments. I will go back in the Z-axis and I will come until I just lightly touch the face of my part. I will go into my X-axis and I will give myself a nice face on the front of my part. As I look down here, I can see that I am getting majority cleanup on my part. With that being said, I'm going to come all the way back up. Without moving my machine in the Z-axis, I'm going to come back up to my controller and I need to set the tool's length in the Z-axis. To do this, I will go to the offset button under display. If you notice, that will take me to my tool geometry page. If it comes up with a different page, for example, my work 0 offset or my tool wear offset, you simply have to just hit the offset button again to get to your tool geometry page. As you can see, tool 2 is loaded into my machine and it is also the tool that is active. I will highlight my Z-axis in my tool geometry page and I will simply push Z face measure. That 14 inches, 134 thousandths, is the distance from the machine's home position to the face of my part. If I was using a tool eye, this number would be smaller because it would be from the machine's home position to the tool eye's position, at which point we would have to utilize our work offset page. Doing it this method, we do not have to utilize our work offset page. We only have to worry about our tool geometry page. Now that we have my Z set, let's set our X axis on our tool geometry. To do this, I will go back into handle, and I'm going to come up to my tool, up to my part, and I will slowly come down onto my part until I make a cut. You will see that I am now making a cut. I'll go back a little bit to make sure I have enough, and then I'm going to just simply come back this way slowly. Now if you'll notice, I am not going to move my machine in the X-axis. I'm going to only move it in the Z-axis. I will increase my feed increment to move out of the way so that I can get a reading. So I'm going to stop my machine. I'm going to use my micrometers, and I'm going to get a reading on here. On my reading, I am getting 2 inches, 226 thousandths on the OD of this part. So we have to remember this number because we're going to come back to my page. Under my tool geometry page, I'm going to arrow over to my X axis, my X tool geometry input. I am going to come down here and I'm going to push X diameter measure. If you notice, I have a value that has been inputted into there, but if I come down here, it wants me to enter the diameter of the part that I just made a cut on. I will delete the previous value from my machine. I will now put in 2 inches, 226 thousandths. I will push right enter, and if you watch my number up here, it has changed to 10 inches, 278 thousandths. That is the distance from home to the center of rotation on my spindle. That means that if I was to command this to X0, the tip of my tool would be at the center of my part. Now that we have this tool set, I can now set other tools. For example, we're going to set our tool 6. Before we set our tool 6, do you remember how I told you this 432 was very important? It is. If I am using tool nose radius compensation to create my part, I will not notice the difference on my straight or vertical parts of my material. However, if I am doing a radius or a chamfer, my tool nose radius will have a big impact on that because it will not make my part correctly. So I will come to offsets. I will find my tool geometry page. This tool is a 432. That tool has that 2 on that description means that my tool nose radius on my insert that I am using is 31 thousandths and 5/10. That is the style. There's more information later that we can look up. For this example, I'm just going to plug in 0.0, 31 thousandths and 5/10, and I will hit right enter. Also, if you move over here, there's something called a tip. This tip represents the tip direction. Now this machine, when you're looking at it, has 4 quadrants. Okay, I have my quadrants and I have my quadrants. Okay, so I have 4 quadrants. I want my tool to be in this quadrant. So that way I'm on the outside of my part and the face of my part. So to be in this quadrant, I need to have a 3 right enter in my tip direction. Now that this tool is set, I can now come to my next tool, which is going to be tool 4. I will go into MDI and I will hit tool 4, turret forward. Tool 6, turret forward.